Thank you so much for joining me as we go over this review sheet for the semester test. We're going to begin here by looking at significant figures, but the first thing I want to remind you of is this. You will really benefit most from this video if you watch it and stop it occasionally to think about what you're doing or to work on to the next problem ahead of the video or just to reflect on your understanding of the concept we're talking about. So, back to significant figures. A here has one significant figure because these zeros are not significant figures. The rule for significant figures work like this. Let's look at C to explain the rules for significant figures. A zero is significant if it lies between two significant figures. And a zero is significant if it is both after the decimal, right there, and the final digit. So those zeros are both significant digits. Coming up over here to B, this zero is not a significant digit because it is not at the end of the number. So not a significant digit. This zero, however, is a significant digit. So D, 5 significant digits. This is a significant digit because it's both at the end of the number and it is after the decimal. Now, keep in mind, I just want to remind you that the whole purpose of significant digits is not to say that these digits are not important. Oh, they're very important. But the significant digit is simply there to indicate the precision of the instrument you're using to make the measurement. And so these are the digits that indicate how precise the instrument was. That's what significant digits are about. So as we move on to nuclear symbols, nuclear symbols, remember, show right here the number of protons. Now that also is the atomic number when you look at the periodic table. So that's how you can find that number, is by looking at your periodic table. The number on the top, right here, that number on the top is the mass number. And so remember, the mass number is the sum of the protons in the nucleus plus the neutrons in the nucleus. So here, if we're looking at manganese, notice that's manganese, not magnesium. We look at the atomic number on the periodic table and we see a 25. And here we see it has a mass of 55. So we know what goes right here, 55. So to do silver, we take a quick look here at the periodic table. Oops, there we go. And we find silver. And we see, oops, I didn't get out my pen on that page. We look at silver and we see its atomic number 47. So when we go to our worksheet, we put the atomic number right down here, number 47. And if it has 61 neutrons, that means it has 108 for a mass number. And so that's how you answer these. So I'd encourage you to take just a moment and check those answers and see if they look right to you. I've made some little notes here that kind of indicate how I calculated some of those, like here with selenium, right here. Calculated the mass number by adding the protons and neutrons together. So look those over, see if I made any mistakes, then we'll move on to naming compounds.
Where would I find the mayonnaise, Jerry?
So let's take a look at naming compounds. Here we have an ionic compound starting with a metal, and so we're just going to name it as the cation and the anion. So the cation is barium, and the anion, NO3, is nitrate, barium nitrate. As we move on to B, this starts with a nonmetal. Nitrogen is a nonmetal, and so we name this using prefixes. It's nitrogen dioxide, 1 nitrogen, 2 oxygens. Now, a lot of you are saying, I am looking at my common ion sheet, and I see an NO2. How come it isn't nitrite? Notice, if you look carefully, the nitrite has a charge of -2. And so nitrite is not the same thing as what we have written here. So this is not nitrite. This is nitrogen dioxide. So here we have copper 2 chloride. Why copper 2 chloride? Well, remember, if copper, since it has more than one oxidation number, more than one possible charge, we have to figure out its charge. So what is its charge? Well, chloride has a charge of -1, and we see 2 of them here in this compound for a total negative charge of -2. Well, of course, that means the copper has to have a total charge of +2, because those charges have to add up to 0. Well, there's only one copper atom there, and so, or copper ion there, so it must be a charge of +2. Therefore, copper 2 chloride. Remember, this Roman numeral is not how many coppers or chlorides there are in the formula. This Roman numeral is the charge of the cation. Now, moving to D, there are a couple of things you could put here. First of all, it does start with a nonmetal, but remember, hydrogen sometimes acts a lot like a metal. This is not a binary compound, so you can't use prefixes. So a lot of you are going to say hydrogen carbonate, and that's going to be just fine if you say hydrogen carbonate. Or if you look on the other side of your common ion sheet, there's a list of acids, and this would be listed there as carbonic acid. Either one of those would be acceptable. Yeah, they'd be acceptable to me. And here we have a ionic compound. I know it's ionic because it starts with a metal, and this is lithium fluoride. Don't need a Roman numeral. So you may want to pause the video here and go on and make sure you can answer all of the questions in number 4. Okay, let's see how you did on number 4. Remember that when you see this Roman numeral, that's the charge of the ion. So this has to be lead with a charge of +4. And you say, what? My common ion sheet doesn't have lead with a charge of +4. What are you doing? And I say, you're smarter than your list of ions. Because you know that if it has to be +4, that's what the Roman numeral is. So if we have the acetate ion, and there are several ways to write acetate, you can use either of them. I'm going to use C2H3O2 with a -1 charge. Well, if these charges are going to add up to 0, we have to have 4 of these. That's the reason for the parentheses. and a 4 out here to indicate we have 4 of these polyatomic ions. So when you write the formula, though, it shouldn't have anything in it except this. No Roman numerals. It's one thing I see a lot of people doing is putting a Roman numeral in here. No Roman numerals. Strontium chlorate. Strontium, remember, he may not be on your common ion list, but you know how to tell what its charge is. It is in group 2 on the periodic table. Let's see if I can bring that up here. Strontium right here in group 2, those all have a charge of +2. So strontium is 2+. So if we have chlorate, ClO, that's a 3, isn't it? We have to have 2 of these. We need the total positive charge is +2. The total negative charge has to be -2. But this is only -1, so we have to have 2 of them. And we would write the formula like this. Phosphoric acid, be sure you look at the back of your common ion sheet. Triphosphorus heptachloride. We know anytime we see this, we've got these prefixes. Now, you don't have to have those prefixes memorized. You know where to look for them. That's right, on your common ion sheet. So here we have triphosphorus heptachloride. Copper 1 sulfide. Remember, that Roman numeral just tells us the charge. It doesn't tell us how many of anything there is. And the sulfide, you know, is 2-. So if I'm going to make these charges add up to 0, I have to have 2+ and 2-. So how do I get 2+? I have 2 of these, 2 coppers.